Hello, so in this circuit we see an impedance ZO is given as shown and it's connected as shown. So we have two impedances connected, each of them named as ZO, and they are connected in series. Now across this impedance network or circuit we have a 2 volt voltage source connected as shown, and let's say we are asked to calculate the voltage across this impedance Z0. So as we can see, we can actually calculate the current flowing through the circuit first, which is I. We apply the Ohm's law, and Ohm's law says I equals to V over total impedance Z0. ZOT is the total impedance, so it would be 2 volt, that is the voltage, divided by Z0 plus Z0 or 2Z0. So divided by 2Z0, and it would be 1 over Z0. So the I is 1 over Z0. So if Z0 is equal to 1 ohm, then I would be 1 divided by 1 ohm, that is 1 ampere. This is how it looks like. All right, so you can see that. So we can also apply a voltage division rule if we want to know the voltage across this resistor Z0 or impedance, because this is Z, so we'll call it impedance instead of resistance. So we can say that this V right here can be equated to Z0 divided by Z0 plus Z0 multiplied by 2 volt. So it would be Z0 divided by 2Z0 multiplied by 2 volt. So Z0 and Z0 gets cancelled, and it would be 2 volt divided by 2, that is equal to 1 volt. So since the values of Z0, there are two Z0s and they are equal, so the voltage drop across this Z0 would be half the total voltage into the circuit, which is 2 volt divided by half, that is 1 volt. Similarly, the voltage drop across this Z0 would also be 1 volt. Okay, and if the values of the resistors, or I would say impedances, are known, then you can also know the values of the currents into the circuit, current through all the resistors, current into this network or the circuit, and that's how you can simply apply the Ohm's law and Kirchhoff's law, etc. How about applying the Kirchhoff's voltage law? Kirchhoff's voltage law, or KVL, states that sum of all the voltages in the loop is equal to 0. So you will start from this voltage source, which is 2 volt, minus voltage across this Z0, VZ0, minus voltage across this Z0, that is VZ0, is equal to 0. So if you know these two voltages, accordingly you can put the values, and accordingly you can complete the loop. So we have seen in this circuit how to calculate voltages and currents across resistors in the loop inside the circuits through Ohm's law and the voltage division rules. So if you like this video, share it with others.